When dealing with the subpanel that exclusively serves 120-volt circuits, determining the appropriate neutral conductor size is crucial for safety and code compliance. Even though there are no dedicated 240-volt circuits, the neutral conductor must be adequately sized to handle the potential unbalanced load from both legs of the feeder. In the scenario where the subpanel is fed by a 50-amp 2-pole breaker, it might seem counterintuitive to size the neutral for 100 amps. However, this is indeed the correct approach. The rationale behind this stems from the understanding of how current flows in a 120-volt circuit and the potential for unbalanced loads. In a balanced system, the current returning on the neutral conductor would ideally be minimal, as the loads on each leg of the 240 volts feed would be equal, effectively cancelling each other out. However, in reality, loads are rarely perfectly balanced. There is always the potential for one leg to carry significantly more current than the other. Consider a situation where all the 120-volt circuits connected to one leg of the 240 volts feed are heavily loaded, drawing close to 50 amps, while the circuits connected to the other leg are lightly loaded, drawing only a few amps. In this case, the neutral conductor must carry the difference in current between the two legs. If the neutral is undersized, it will become a bottleneck, leading to overheating and potentially a fire hazard. The National Electrical Code, or NEC, provides guidelines for conductor sizing. While specific tables and articles should always be consulted for the most accurate and up-to-date information, the general principle is that the neutral conductor should be sized to carry the maximum unbalanced load. In the case of a subpanel with only 120-volt circuits, the maximum unbalanced load can be considered to be the full capacity of the feeder, which in this case is 100 amps due to the 250-amp breakers. Therefore, the neutral conductor must be sized to handle this potential current. It is important to note that there are some exceptions in specific situations where the neutral conductor size can be reduced. For example, if the load consists primarily of nonlinear loads such as electronic equipment with switching power supplies, the neutral conductor may need to be oversized due to the presence of harmonic currents. Harmonic currents are currents with frequencies that are multiples of the fundamental frequency, which is typically 60 Hz in the United States. These harmonic currents can add up in the neutral conductor, even if the loads are balanced, leading to overheating. In such cases, the NEC may require the neutral conductor to be sized at 200% of the ampacity of the ungrounded conductors. Another situation where the neutral conductor size can be reduced is when the feeder supplies a range, a cooktop, and an oven. In this case, the NEC allows the neutral conductor to be sized based on a demand factor, which takes into account the fact that these appliances are not likely to be used at their full rated power simultaneously. However, it is crucial to carefully consider all applicable codes and regulations before reducing the neutral conductor size. In general, it is always better to err on the side of caution and size the neutral conductor larger than necessary. This will provide an extra margin of safety and ensure that the electrical system can handle any potential future load increases. In addition to the neutral conductor size, it is also important to consider the type of conductor used. Copper conductors are generally preferred for electrical wiring due to their high conductivity and corrosion resistance. Aluminum conductors can also be used, but they must be sized larger than copper conductors to carry the same amount of current. The NEC provides tables that specify the ampacity of different types of conductors based on their size and insulation type. It is important to consult these tables to ensure that the correct conductor size is used for the application. Furthermore, the connections to the neutral bar in the subpanel should be properly torqued to prevent loose connections, which can cause overheating and arcing. Regular inspections of the electrical panel are recommended to identify any potential problems such as loose connections, corrosion, or damaged conductors. A qualified electrician should be consulted for any electrical work, including the installation of subpanels and the sizing of conductors. Improper wiring can be dangerous and can lead to electrical shock, fire, or other hazards. Therefore, it is essential to follow all applicable codes and regulations and to hire a qualified professional for any electrical work. To summarize, even in a subpanel that only feeds 120-volt circuits, the neutral conductors should be sized to handle the potential unbalanced load from both legs of the feeder. In the case of a 50 amp 2-pole breaker feeding the subpanel, the neutral conductor should be sized for 100 amps. There are some exceptions to this rule, such as when the load consists primarily of nonlinear loads or when the feeder supplies a range, a cooktop, and an oven. However, it is crucial to carefully consider all applicable codes and regulations before reducing the neutral conductor size. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult a qualified electrician for any electrical work. When sizing the neutral, firstly, consider the total potential load served by the subpanel. Secondly, account for any dirting factors specified by the NEC based on the type of load. Thirdly, use appropriate NEC tables to determine the correct wire gauge for the calculated amperage. Fourthly, ensure all connections are properly torqued and that the neutral bar is adequately sized to accommodate all connected conductors. Fifthly, label all circuits clearly to facilitate future troubleshooting and maintenance. Sixthly, consider future expansion plans when sizing the neutral conductor to avoid having to replace it later. Seventhly, document all wire sizes and calculations for future reference and inspections. Eighthly, verify that the grounding system is properly installed and bonded to the neutral at the service entrance, not at the subpanel. Ninthly, use appropriately rated connectors and terminals for the wire gauge being used. Tenthly, conduct a thorough inspection of the completed installation to ensure compliance with all applicable codes and regulations. It's essential to understand that the neutral conductor carries the return current from all the 120-volt circuits in the subpanel. If the loads on each leg of the 240 volts feeder are not balanced, the neutral conductor will carry the difference in current between the two legs. For instance, if one leg is carrying 40 amps and the other is carrying 10 amps, the neutral conductor will carry 30 amps. This is why it's crucial to size the neutral conductor to handle the maximum potential unbalanced load, which in the case of a 50 amp 2-pole breaker is 50 amps. Furthermore, the NEC mandates specific requirements for conductor sizing based on various factors, including the type of insulation, the ambient temperature, and the number of conductors bundled together. These factors can affect the ampacity of the conductor, which is the maximum amount of current it can safely carry. Therefore, it's essential to consult the appropriate NEC tables to determine the correct conductor size for the specific application. In addition to the neutral conductor size, it's also crucial to consider the size of the grounding conductor. The grounding conductor provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. The NEC specifies the minimum size of the grounding conductor based on the size of the circuit conductors. It's also important to ensure that the grounding conductor is properly connected to the grounding electrode system, which typically consists of a ground rod or metal water pipe. This ensures that the electrical system is properly grounded and that fault current can flow safely back to the source. When installing a subpanel, it's crucial to follow all applicable codes and regulations and to hire a qualified electrician to perform the work. Improper wiring can be dangerous and can lead to electrical shock, fire, or other hazards. A qualified electrician will have the knowledge and experience to ensure that the subpanel is installed safely and correctly. Moreover, regular maintenance of the electrical system is essential to ensure its continued safety and reliability. This includes inspecting the electrical panel for any signs of damage or corrosion, tightening any loose connections, and testing the circuit breakers to ensure they are functioning properly. It's also important to keep the electrical panel clean and free of any obstructions. By following these guidelines, the electrical system can be operated safely and reliably for many years to come. Therefore, remember that proper neutral sizing is not merely a matter of code compliance, but a fundamental aspect of electrical safety. An undersized neutral can lead to overheating, insulation damage, and potentially a fire. It is always best to consult with a qualified electrician to ensure that the electrical system is properly designed and installed, prioritizing safety and reliability.